Okay, for today, it is the next one's after sine and cosine. So we'll start by reviewing sine and cosine, and then we'll get to a quick review of tangent, and then the other three: secant, cosecant, and cotangent. Yes?
Are you supposed to be recording?
And I am, but you can't see it on your on there, unfortunately. So I'm recording to explain everything. And thanks for reminding me. All right, so to begin with, let's graph nice, simple sine graph. Okay, keep going. Just start blank. And I don't recommend using graph paper for these. Otherwise, you have to try to pick exactly how many boxes need to be your x-axis and your y-axis. Here, you just make it look like that. Raise your hand if you graphed it generally right. Okay, good. And pretty much everybody gets the wave right, but do you know what the 5? You don't have to label 0, but there's 5 spots. 0 is one of them. These 4 are more important. I don't require you labeling 0. But how does it end? If you know how the story ends, you can always back it up to halfway, etc. So this thing has a period of 2 pi. Good. And so half of that is pi. And then you go half of that. 1/2 pi, otherwise known as pi over 2. Good. And then this one is in between, and that's the hardest one. Who knows what that one's called? 3 pi over 2. If you get stuck on that, then I would count it up. 1 pi over 2, 2 pi over 2, 3 pi over 2, and that's 4 pi over 2. And it really makes sense if you count them up by pi over 2s. Okay, then don't forget the x and y axis labels. You don't want to lose points on things like this. Like, I didn't label it. Crap. There goes my R2s, and if you don't get enough R2s right, even if you ace the R3s, the max in this class you can get to 90. So you've got an A minus just for screwing up the little things. All right, and that's if you knew everything else. All right, so then that was sine. I hope you remember cosine's very similar. Would you take a moment and try to graph cosine, please? In a moment, I'm going to ask you to compare it with the kid sitting next to you. It'll be these 2 rows. You do not have to slide next to each other. You're just going to compare across. And it'll be you 2 guys, and then everybody else is across from somebody. And these 2 rows, the person that you're across from. Check and see if you and they agree on cosine. I'm going to pause for a second while you give that a try. Okay, I'm recording again because I have started graphing cosine. If you haven't already, can you check, not just with the shape, because that's pretty easy. Check and see if they have the same label right there in the middle. Would you please, if you haven't already, compare your labels with the kid sitting next to you. The labels on the x-axis. And I goofed up 1 mark there. That's the middle, and that's the middle. So then there's 2 pi here, pi here, pi over 2, 3 pi over 2. Those are the same exact numbers as last time, they just kind of in different places. And then this peaks out at 1, drops to -1. Just a quick reminder on words. What's this called, domain or range? That is domain, very good, and obviously the other one is range. Okay, now let's say instead the test question was more, because this is more likely to be what it's like, even for an R2 level, for cosine of 2x. The 4 is super simple. You would take the same graph. Please don't erase the whole thing. That'd be dumb. Take the same graph and just relabel it. Can you tell me what the 4 does?
The 4 makes the amplitude larger, so instead of going to 1 and -1, it goes to 4 and -4.
Very nice. He said, for those at home, the 4 makes the amplitude bigger, and so it goes from 1 and -1 to 4 and -4. All right, so that is called the amplitude. Very good. And then how about that b term? Do you remember there's a little equation? Something, something over something. That gives you this and the period and stuff. Does that ring a bell? Let's do phone a friend. I know you'll find it if you look eventually, but what do you find? What do you think? You don't remember? Okay. You guys need to know this by Friday. Really critical. Oh, found it.
2 pi over b.
2 pi over b. Good. So the period is 2 pi over b. So what's our period right at the beginning? 2 pi. But then we got to divide by b. What's b? 2. So then if b is 2, we're going to take 2 pi over b, divide by b, or 2. Multiply by a half is the same as divide by 2, right? There you go. So you're going to want to divide by that down here. And notice, I didn't have to change my cosine graph a bit. We're not making you redraw them. That would be a real pain. So this saves you a ton of time. The only times that you have to redraw it is if it's been shifted. So let's imagine for a moment that the question was actually take that 2x, take the 2 out of there, and let's instead put in a, here, just a second, I'll erase that. X minus pi over 2. That means I got to move my graph. What do you think it means? Which way?
Right.
Yes, to the right, pi over 2. And then how far is pi over 2? I can see it. Can you see it? It's this distance right here. That's how far it needs to move. So you just grab yours if you were using an iPad. On the test, of course, you won't be using an iPad. I just take and move every dot over one tick mark. So that dot that used to be right there is now going to be over here. And this dot that used to be down here is going to be over here. Get what I mean? Every single dot. That dot is now going to be to the left of it, 1 mark. And then that dot is going to be to the left of it, 1 mark. And now it starts here. There. It's the same thing. It's just moved. My valley has moved 1 spot to the right. Okay. And then the other thing that can make you have to regraph them is if I put a flip in there. Get it? If there's a negative in the front, the whole thing flips upside down. The one thing we pretty much never do is a negative on the inside. It's just really complicated and it's not worth it for the level of trig that we're doing. So it's not even that complicated. It's just something that we aren't messing with right now. There's about infinite things you could teach on trig. Remember, this class used to be an entire year just for trig. And this is only, it's pared down to pretty much a quarter, a little over a quarter. So there's a lot of things in trig that we've let go of. All right, so now what do you have to learn next? You have to learn how to do things like, well, wait, this, I do want to pause for a moment, not the new stuff quite yet. We have chapters 14, 15, 16, 17, 18, and 19, and then a final. Well, it's a good thing we have a whole nother quarter, okay? So we have 6 chapter tests, one of which we're about to take on Friday of this week on this stuff, okay? Then you're down to 5 after that, and then the final. Why am I saying this? Because the final at the end of the year, it's hard to remember all that stuff. So what we've done, and this has worked well in the last few years, is we do a lot of review. Like starting now, we start reviewing the stuff we've already had first semester, and like things you just took, like you just took a circle trig test not long ago, right? And then you had this identities test just recently too. And you guys generally did really, really well. But I want to remind you how to do this stuff. So you're going to see on your tests questions from past tests. So you are going to be responsible for remembering. We're not going to put the most complicated stuff on there, but we're going to put the basics from previous units on future tests. I guess that's all the more reason why you should do corrections and retakes if you ever bomb a test, because then that means on the next test there'll probably be some of that again. All right, so let's talk about that right now. This is a proof. And my first thing is I normally look at the left side and say that's the more complicated side. But just to kind of get an idea of where I'm going, even though it's not legal for me to change both sides, I can look at this and say, ooh, I know what that one is. And I know you don't have the sheet right now. So we'll let some smart kid be our sheet. Who remembers sine of 2 theta? It was on the test multiple times. Yes?
2 times sine times cosine.
Yes, 2 sine theta, cosine theta. All right, I should use x's because it's in the context of x. Nice work. 2 sine x, cosine x. Okay, if you'd forgotten that, you're not a bad person. And for that, we will still let you use a review sheet for identities. You can't use it for other tests where we didn't have review sheets. On the big old final, every time we gave you a formula on a test, we will give it to you again on the final. But we won't give you any other ones, like if we didn't ever give it to you before, you gotta know it. All right, so this is said in context of, now I know that I want things in sine and cosine. Because otherwise kids will go, oh, cotangent, that's 1 over tangent. But that's not the way we want to go. We're trying to prove it's sine and cosine. So don't change cotangent into 1 over tangent. Change cotangent into cosine over sine. Would you please just take a moment and prove the first one? Remember, cotangent is cosine over sine. You should be able to prove this one. Pause for a second while you try that. Okay, I'm hoping you figured out that this one was cosine over sine, and the other one was sine sine. This can cancel this. Therefore, it's 2 cosine sine. That is not a proof. I'm writing with my finger right now because I have misplaced my Apple Pencil, so I'm not going to try to write that out perfectly, but that's how it should have generally gone. Raise your hand if you had that one right. Awesome. Do you guys remember that 1 plus tangent really doesn't do us much good? So you could use what's called a conjugate. No, wait a minute. This one actually works. My bad. This is on the sheet. Who remembers a dumb saying? 1 with the tan is what you seek. So that's a secant squared down there. And then 1 minus tangent. Ooh, wait a minute. What the heck? 1 minus tangent. Could that be... Oh, wait a minute. We could replace tangent with 1 over cotangent, for example. But how do I know where to go? I would look up that on the sheet. I would look up cosine of 2x. I know you don't know it. It's not a common one. There's actually 3 things it can be, so that might be one of them. All right. But anyway, you'd look up on the sheet, what is that? So I can figure out if I want to get things in tangents or cotangents or cosines or what. Okay, enough review about that. I do want to take just a moment to do some review, hold on a second, of this kind. I have found on the ACT also, this kind of question comes up tons of times because it's testing you on so many things all at once. For example, sine of some angle I don't know is equal to negative root 3 over 2. It tests you, first of all, do you even know what they're asking? What are they asking? They want an angle. Good. Second of all, they're testing if you know that there's actually 2 places where sine is negative and therefore 2 angles. Third, they're testing, can you draw a triangle in the right quadrant and label its sides and angles? And then, once you got a triangle, let's say you draw a triangle here, which isn't right, by the way, but if you did, you'd have to remember that, oh, the angle is actually that angle. It's not the little angle on the center, the central angle. It's the big angle going around to the outside like that. So it tests you on so many things. So I'm going to have you try it right now. Imagine that this is our test, and this is just popped up as a review question. Remember, your final answer are angles, and they're not in quadrant 1 because sine is negative. All right, I'm going to pause for a sec while you give that a try. All right. Did you realize that since sine was negative, all students take calc, so positive and positive. So therefore, has to be down here. And sine is opposite, negative root 3 over hypotenuse, 2, and that must be 1. And then what's across from this angle? The bigger one, so that's a 60. But I don't call it a 60, I call it a pi over 3. And then I remember this is 3 pi over 3 plus 1 more makes 4 pi over 3. Now, a lot of people probably did it in degrees. Do you realize that the last test and this coming test will want it in radians? You lost sometimes nothing, depending on the problem. But you lost at minimum 5% if it was counted off. That hurts. Why lose 5% when you can just use radians? Okay, and then the other one is even more pi over 3s. We got the 4 pi over 3. The next one where 5 pi over 3 would be is right here. And that's where the next one is, 5 pi over 3. So 4 pi over 3 and 5 pi over 3. Raise your hand if you actually had that one right. Okay, it's about half of you. That means some of you guys need to study this more. All right, so now I get to teach you, well, tangent I already taught you, but I'll just remind you. Do you remember how tangent kind of looped through there like that? That's a little sloppy. I should probably zoom in and do a closer, careful job. Goes through 0, 0. And then halfway here and halfway here are kind of big deals. Pi over 2, pi over 4, because it's half of this. Think about that. 1/2 times that would be pi over 4. And negative pi over 2 and negative pi over 4. There was your classic tangent graph, where that hits at 1 and that hit at -1. Okay. So right now, if I asked you to stretch it or flip it or move it, you got the parent graph. All you got to do is, well, let's say I threw in A2 right there. Well, that's super easy. Too easy, in fact. You just change the 1 and the -1 to 2 and -2. That's really, really easy. What if this was a 5 in here, though? Okay, well, I don't multiply all these by 5. I divide them all, because the period is 2 pi over b. But wait a minute. Just to clarify, the period of tangent is not 2 pi. Have you noticed this yet? This distance from across here, its period is pi. So if you want to know this guy's period, it is not 2 pi over b, because it's tangent. So it's pi over b. So its period is pi over 5. So I take and divide everything by 5, or multiply everything by 1/5. So I'm going to put a 1/5 by each of my little markings here. So I think some of you missed that. I'm going to say it one last time. This period is a 1/2 a pi this way and a 1/2 a pi that way. It makes a total of 1 pi across. And that's a big deal about how tangent is different. Okay. So now what are the new ones? The new ones are, so here's secant. Secant. Do you remember me saying, don't ever do secant? Instead, you go do the sister function, and then you just flip it, right? This is kind of like that. We're not going to start by graphing secant. What do you think I'm going to start by graphing? The sister function, which is cosine. Good. I'm going to start by graphing cosine, and I think you should too. Everybody try to remember how cosine looks. It's a big old valley. And now secant. I saw that. Get back with me. You have to double tap your iPad when I walk your direction. I know what you're doing. I know. There's other more fun things to do than math sometimes. I need you with me. All right, so secant rides on the back of its sister function. So it's here and here and here. They're little loops. I'm going to try to move this over so I can complete the loops. There we go. And what do you think happens when its sister function hits 0 right there? What do you think 1 over 0 is? It's undefined. So that means you have to have an asymptote there. And you have to have an asymptote the other spot where it hits 0. Right there. And how far apart are those asymptotes? Pi. Good. That happens to also be how far apart the asymptotes are on tangent. And also the same distance the asymptotes are apart wherever you see them. They're always pi apart. Say pi apart. All right. That'll help you remember it. Okay. Now, where the asymptotes start isn't always the same, but they're always pi apart from each other. Now, you can always stretch that, or shrink that, or, you know what I mean? They can be moved, but they start out as pi apart. Okay. That's what secant looks like. What if I had to do 2 secant? Well, then the the y-axis labels would just get doubled. What if I had to put a 7 inside there? Well, then I figure out what these labels were, which was 2 pi and pi over 2, and I multiply everything by 1/7. It's really not that bad. It's 1 over whatever that is, or divide by 7 on all my labels. All of these. All right. Cosecant. And the next page. Cosecant. Guess what? Refuse to do cosecant. Instead, start with sine. Yeah, remember how sine goes? Graph it. Label it. And then remember that we're not actually supposed to be graphing sine. But it's helpful because the sister function will just ride on its back like this. And where are the asymptotes? Whenever the red one hits 0. I'll make them yellow. How far are the asymptotes apart? Pi apart. Could that change? Yeah, if we horizontally shrink it or stretch it, that'll change. But there you go. That's cosecant, the blue one. If my iPad were as smart as yours, I could just erase the red one with one touch, but I can't. So imagine, maybe I can, here, let me try something. Try to get out a super small eraser so I can be super accurate. Try to erase just the red part. I nicked my blue one. That was an artery. The patient would bleed to death.
Patient's dead.
Hopefully that wasn't a brain surgery kind of thing and just lost a bunch of memories. Did I tell you about my friend who had brain surgery and it actually came out nicer? Okay, so that's cosecant. What's left? And cotangent. Cotangent. So you don't start by graphing cotangent. You start by graphing tangent. So everybody try to put tangent on here. And I know it's a little bit of a pain because it's over here. Oh, yellow's the worst color. I'll try that again. There's tangent. And how far apart are the asymptotes? It's actually the same on this one. Pi apart. Because that's half a pi, another half a pi. The asymptotes are pi apart. Okay. So then, that's pi, not pi, it's pi over 2. And that's negative pi over 2. Now, what's the critical thing with cotangent? It's its sister. So that means it's 1 over that. So how do I do 1 over this? Well, you just have to remember that whenever this hits 0, 1 over 0 would be a problem, right? It would be an asymptote there. So there's going to be an asymptote running right there. And how far apart are the asymptotes again? Pi apart. So here's the other asymptote over here at pi. All right, so now this is getting really messy. So honestly, this is the one where I don't think you need to graph the parent one, except I bet you get this. A ton of kids are going to do cotangent by flipping this way and leaving it right there. Do you get that that's not right? What do we just say about the asymptote? Wherever it hit 0 originally, that has to be an asymptote. So it is that shape, but the asymptotes are in different spots. My eraser's still a surgical eraser. I got to get the big one out. A lot easier to erase with this guy. Okay. Then asymptote, asymptote that are pi apart. And then cotangent goes like that. Make sense? Even if it doesn't make sense, that's where it is. Okay? And this is pi, and that's 0, because you know where 0, 0 is, so. And the asymptotes are pi apart. Why was there an asymptote here? Because the original graph hit 0 right there, and cotangent is 1 over that, so. Okay, so if that's pi over here, what's there? Pi over 2. This one's only got 3 critical numbers. Ideally, you'd know that here and here hit 1 and -1 also, but and if I wanted to know what it was, it'd be half of pi over 2, which is pi over 4. And then I go 1 pi over 4, 2 pi over 4, and 3 pi over 4. Okay, so there's cotangent. So what the heck is 40 cotangent? Well, that's easy. Instead of having 1 and -1, I change it to 40 and -40. Those are always super easy. That's where it's always going to get weird. And that's the b term. And remember, it's not 2 pi over b, because this is based on cotangent, which is based on tangent, which has a period of pi. So it's pi over b is what the period is. It's easy to forget that and go back to the old formula, which we used on the other ones, which was 2 pi over b. Okay, so then I got to put the pi over 2 right here. And if you're good at flipping, you realize this is pi times 2 over pi, and then the pi's cancel, so the period is just 2. Notice not 2 pi, just 2. I'm going to divide everything by pi over 2, which is the same as multiplying everything by 2 over pi. 2 over pi. 2 over pi, and 2 over pi. Cancels. Okay, so I know those got a little bit intense, and you did practice now. And luckily for you, we have practice. So this first one is one of those review problems. I want to do one with you. I'm only assigning A and B off of this page. And I hope that you could agree that I have been pretty good about shrinking your assignments down. Now you be pretty good about doing the ones I give you, and it'll help so much. If I make a picture of this, it's just like the one we just did. It doesn't know the angle. So what do? You draw a triangle and you label its sides. It says it's in quadrant 1, so I'm going to draw it here. And cosine is adjacent over hypotenuse. Adjacent is 1. Hypotenuse is square root of x squared plus 1. So what's the third side? Because that's all you really need. If you're going to try to find tangent here, that's the goal, find tangent, then you need opposite over adjacent, right? All you need to do is have that side and you got it. So what is that side? You got to figure out these two numbers got put in there. So I know we're at different levels of ability in here, but this one, 1, and once somebody tells us, I hope it'll be obvious. Somebody in here's got it. I heard x, I heard x squared. Think about it further. What one of you two is right.
X.
Agreeing on x. Okay, good. Because then you square it and put it in here, and you square it and put it in there, right? Now that you see that, hopefully that'll be like, oh, I get how that must have been x. If you had to, you could set up a squared plus b squared equals c squared and solve. But this side is x. So now what's the final answer? Tangent. So tangent is TOA. TOA is opposite over adjacent. Final answer is the tangent of theta. Now that I got the picture drawn, it's always easy. It's all about drawing and labeling that picture. Because now it's just x over 1, which is just x. You do one. That's the one you need to do. I showed you how to do the first one. All right, next page. All I'm asking you to do on this page is the first one and the last one, so you can scribble out this middle one. Now let's start it together with this A, B, C, D thing. A is the amplitude. It's super simple. Don't overthink it. What do you think the answer is? 2. It's that number right there. Okay? It's 2. What's the B term? It's the number that's in front of the angle. So what's that? 1/4. What's our period? Hint, what's the formula for the period? But not if it's tangent. Pi over b. And if it's tangent, remember that formula changes to pi over b. So then it's pi over what? 1/4. And then you should be able to simplify that. Horizontal shift, there isn't one. That's where it would be. If there was a shift, it'd be right there, but there's no shifting going on. Not very shifty. Then the last one is that, and that is the what? The vertical shift. Very good. And that's also D. And C, there wasn't one, so you could just say none. Or you could argue that the, well, actually, no. Well, I could argue that the C is 0 because you're adding C in there. Like that would be added C, so adding 0. Maybe I should call it 0. And D was -3. Then you actually need to graph it. My advice, don't use these little terrible graphs. A teacher was trying, but I think it's best to just give yourself a nice blank post-it, slap it in there, make an XY axis. You can draw it any scale you want that way. It's so hard to try to follow where the, you know, exactly how far pi is on dots on a graph. All right. And do just these two. I'm okay with you just doing this one and this one. So problems 14 and 23. That makes it a doable assignment for tonight. Yes, there's more stuff, but these are hideous. You don't have to do those. And this one, I'm going to teach you more about that tomorrow. So I'm going to say you can skip the butterfly one too. Okay, that's all I got for you for today. Is today the 18th, 17th? What is it?
18.
Thank you.
So I will be coming on Thursday or Friday. Can I get the test in the testing room before then?
Yes, except I don't even have them yet, so you've got to remind me. Like probably on maybe Tuesday, but more likely Wednesday.
Okay.
Try tomorrow. I might have them by tomorrow.
So check in there tomorrow.
No, what I mean is
Check with you.
just remind me to put it in, because I can't do it until later, and I will totally forget. So.
Okay.
I was gone Wednesday, Thursday, I'll make up the test for the math.
Yes, and for anybody who's absent for that test, I put their name on it and I threw it in the testing room. So there should be one there for you. One last thought: it was on the easier side, but it was also a partner test, which is one of the reasons the results were so good. If you want a partner, then just show up Wednesday during Mass in here, And I'm telling anybody else who missed it, which is quite a few people, that Wednesday morning is their chance to figure it apart. So, all right.
Salt? Oh yeah, I had to have it under my feet when I got in the car. I was salt
HBC is yes, no problem.